in this slide, I'm going to look now at where I'm going to find these real gases deviating from ideal behaviour. Remember, an ideal gas obeys all the assumptions under all conditions of temperature and pressure. Okay? But when I look at what I have, if I have low temperatures, okay, so remember, an ideal gas or a real gas comes closest to ideal behaviour when I have low pressure and high temperature. But what's going to happen at low temperatures? Firstly, if I decrease the temperature, that means, according to my assumption, that I'm also going to decrease the kinetic energy that I have in my gas particles. Remember, this is my kinetic theory, my assumptions. The kinetic energy is proportional to Kelvin temperature. As my temperature increases, proportionality means my kinetic energy is also going to increase. Likewise, if I decrease my Kelvin temperature, the kinetic energy is going to decrease. So this means my particles move more slowly. And when they move more slowly and when they hit off each other, so here I have one particle and here I have another particle. Because my particles are more slowly moving, there is now an opportunity for these two particles to interact. And that means that my assumption number 2, there are now attractive and repulsive forces between them. And these attractive forces can even be quite significant. So that is the first condition under which I have real gases. Remember, my ideal gas obeys all of the assumptions under all conditions of temperature and pressure. But at low temperature, they're not going to agree to this assumption, okay, that there are no attractive and repulsive forces. So because of that, that is one way in which my real gases deviate from ideal behaviour. The second way is at high pressure. Okay, so if I have my system at high pressure, okay, what that means is that my gas molecules are very close together. Okay, so if I take my system, and this is at high pressure, and we'll just say I have two molecules or particles again in here. These are very close together. We can also see that the volume these two particles occupy is pretty much the volume of the container. So if I look at my assumption, the total volume of molecules is negligible to the container, the volume of the container in which they are placed. But if I look at high pressure, in this case, the gas molecules, the total volume is not negligible with respect to the total volume of the container. Okay, so you need to know the two conditions under which my real gases come closest to ideal behaviour, so where they are going to abide by these assumptions, but you also need to know why and where real gases don't abide by ideal behaviour. And the two big conditions are at low temperature and high pressure, and you need to know why. So at low temperature, the attractive forces can be significant, and at high pressure, the assumption that's broken is that the total volume of my molecules is not negligible with respect to the total volume of the container.